So far, we visualize the data. We try to find a linear or nonlinear relation between data by just looking at them. Now, correlation coefficient help us to analyze it a little bit better. Interpreting correlation using a scatter plot can be subjective. A more precise way to measure the type and strength of a linear correlation between two variables is to calculate the correlation coefficient. Although a formula for sample correlation coefficient is given, it's more convenient to use technology to calculate this value. The definition of correlation coefficient. The correlation coefficient is a measure of the strength and the direction of linear relationship between two variables. We use symbol R to represent the sample correlation coefficient. A formula for R can be written this way. R, or the correlation coefficient, is a fraction. On the numerator, you have n times the summation of all x, y's minus the summation of x values times the summation of y values. On the denominator, you have two square roots. The first square root has n times the summation of x squared minus the summation of all x values raised to the second power. And the second square root includes n times the summation of y squared minus the summation of y's to the second. N is the number of pairs of data. So for a little bit, we're going to use paper and pencil to do the calculation for R. Then we're going to use technology to see how we put the data into our either software or calculator and do the calculation. The population correlation coefficient is represented by lowercase Greek letter rho. So when you see rho, it means that you're working with population correlation coefficient. The range of the correlation coefficient is -1 to 1 inclusive. It means that it can be 1 or -1. When x and y have a strong positive correlation, R is very close to 1. When x and y have a strong negative correlation, R is close to -1. When x and y have perfect positive linear correlation or perfect negative linear correlation, R is exactly 1, respectively -1. However, when there is no correlation, we expect R to be close to 0. So in this case, we have a perfect positive correlation. As you can see, the data are lined up on an increasing line. In this case, R is 0.81, which shows a positive correlation, and it is a strong positive correlation. There is no exact line, but we can identify it easily by looking at the behavior of the data from left to right. So from left to right, we can detect a increasing linear relation. It's important to remember that when R is close to 0, it doesn't mean that there is no relation between x and y. You might have a relation, but it might be a nonlinear relation. In this case, R is 0.45, and we see a weak positive correlation. It's very difficult to detect that line. Take a look at this case. Here you have the IQ scores. Well, the IQ score as free variable and the height on the vertical line, it doesn't seem to have a linear correlation. And as you can see, the data are scattered all over XY plane. Two negative correlations for you. One of them is perfect negative correlation. We see the lines are all lined up and it is a decreasing line. Strong negative correlation or is negative 0.92. And as you can see, you have a decreasing trend in the data. Guidelines calculating a correlation coefficient. First of all, find the sum of all x values, which is denoted by summation of x. So let me change the ink color. The sum of all x values, this symbol sigma x represents the summation of x values. In the second step, find the sum of the y values, which is denoted by summation of y's. And the next step, multiply x and y values and then find their sums. Square each x value and then find the sum, the summation of x squared. Do the same thing for your y values. Multiply y values by themselves and then add them together. And finally, follow the formula. On the numerator, you have n times the summation of x times y minus the summation of x times the summation of y's. And on the denominator, you have two square root to work with. The first square root has n times square root of x squared minus the summation of x to the second power. And the second square root includes n times the summation of y squared minus the summation of y's to the second power. So these are the guidelines in calculating a correlation coefficient. Let's take a look at one example together. In this example, here we have the GDP in trillion of dollars, which was our X value, independent value, and CO2 emissions, which is Y, depends on X. For X values, if you add them all together, it adds up to 24.6. For Y values, if you add them together, it adds up to 5,263. Now, multiply X and Y's. For example, if you multiply 1.7 and 552.6, it is going to be 939.42. Then multiply X by itself. 1.7 times 1.7 is 2.89. Multiply Y values together. So 552.6 multiplied by 552.6 gives you 366.76. If you go to the next line, the same process. Multiply X and Y together, 1.2 times 462.3 gives you 554.76. If you multiply X by itself, you get 1.44. If you multiply Y by itself, you get 213,721.29. Continue this process for the rest of the data. Multiply X and Y's, square X, square Y, and then add all of X, Y multiplications. It's going to be 16,145.46. If you add X squared together, this is going to be 79.68. If you add Y squared together, you get 3,412,308.32. Then you can just punch this formula into your calculator and do the R is equal to 10, which which is the number of pairs, times the multiplication of x and y's. When you add them together, as you can see, it is 16,145.46 minus the summation of x values, which is 24.6, the summation of y values, which is 5,263, and divide them by the square root of n, which is 10, times the summation of x squared, which is 79.68, minus the summation of x to the second, so 24.6 to the second, multiplied by square root of n, which is 10 again, times the summation of y squared, which is 3,412,308.32, minus the summation of y values to the second, which is 5,263. Well, this is going to be 0.912. This is R. This is our correlation coefficient. The result, R, which is approximately 91.2%, suggests a strong positive correlation. So, based on the data and the number of correlation coefficient, we can see there is a strong relation between GDP and CO2 emissions.